Welcome everyone. Today we are going to learn about active transport mediated by ATP driven pump. Now at first I will talk about what is active transport. Now in my previous video basic facts on transport I have mentioned there are two different types of movement occurs during the transport of molecules or ions. One is called downhill movement and it is uphill movement. Downhill movement can be understood by this way. Suppose someone actually come down from a hill, it feels easy, it doesn't require energy. So the same is true for molecules. When molecules move from higher to lower concentration, it is called downhill movement or passive transport. Now, if the molecules or ions transported against their chemical concentration gradient, that means from lower to higher concentration, that requires energy, and that's why it is called active transport, because this process is thermodynamically unfavorable. Now here the molecules actually moving from low to higher concentration, lower to higher concentration. Now it is not necessary that always the molecules move from higher to lower concentrations. No, it can also move from lower to higher concentration. Sometimes cells require the movement of these molecules from lower to higher concentration, and that's why it requires active transport. And here is the play of different types of proteins. Now cells carry out active transport in three main ways: coupled transporter mediated active transport, ATP driven pump mediated active transport, and light driven pump mediated active transport. Now I have already made a separate video on coupled transport, that means by symporter and antiporter. If you have not watched this video, you can go and watch the video also. Now in this video we are going to learn about ATP driven pump, how ATP driven pump actually carry out the active transport. Now let's talk about ATP driven pump. Now here also the molecule or ion actually move against their chemical concentration gradient, that means from lower to higher concentration. How we can understand this triangle actually represent the chemical concentrations gradient. As you can see, the base of this triangle represent high concentration, and the peak or the top of this point of this triangle represent lower concentration. And you can see the movement or arrow sign of this molecule is actually from cytosol to the extradia, that means from lower to the higher concentration. That's why it is active transport, because it requires, or uphill movement, that's why it requires the energy, and it comes from the breakdown of ATP to ATP and PI. So basically this ATP driven pumps acts as a ATPase that use energy of ATP hydrolysis to move ion or small molecules across a membrane against a chemical concentration gradient. That means against the chemical concentration gradient means from lower to high concentration. Not only that, this movement can also against an electric potential. Now what is electric potential? Electric potential means membrane potential also, or is a voltage. Actually almost all plasma membrane or all cells actually have electric potential or membrane potential. And it has been found that the inside of the cell is actually negative charge and outside is positive charge. Now both these factor like chemical concentration gradient and electric potential can sum up to make another condition called electrochemical gradient. So at first I will explain why what is electrochemical gradient, then it will help you to understand this fact. So first, suppose this is the first option or first situations where chemical concentration gradient is only present, and these are the actually ions. So here positive and negative ions are more in concentration, so higher concentration present outside and lower concentration inside. So what will be the movement of direction of movement of these ions? From outside to the inside. One thing I want to mention, this electrochemical gradients is also known as ion motive force. So it actually shows the direction of the movement of ions. So at first let's talk about this first situations, that is when only chemical concentration gradient is actually present. So what will happen, the from higher concentration to lower concentration the ions will move, okay, and this thickness of the arrow sign indicates how the rate actually is. Now let's suppose if we add the electric potential factor with also the chemical concentration gradient, as you can see here, the plus signs or plus ions, positive ions, cations are higher in concentration outside than inside. So it means that chemical concentration gradient is actually present for these ions also. That means here the concentration is higher and inside is lower. So this arrow sign will actually indicates that movement will occur from outside to the inside. But here electric potential also adds the factor. So the positive charge is actually almost generally the plasma membrane outside of the plasma membrane is positively charged and inside is negatively charged. So this also favors the movement of positive ions inside the cells, and that's why the thickness of this arrow is C is more than only concentration, chemical concentration gradient. That means this is the electrochemical gradients, and it actually add the ion motive force of the ions. But in case of negative ions, as you can see here, the concentration gradients is actually higher outside than the inside, so the movement will occur in this direction. But you see the thickness of this actually arrow is more thinner than also the chemical concentration, because it actually prohibits the entry of negative charge, because inside is negative, so it will not actually um, promote the movement of negative charge. Now here comes the ATP driven pump. Suppose if we want to move these positive ions from this inside to the outside, what will require? ATP driven pump is required, because the movement of positive ions from outside to the inside is uh, actually increased because of this electrochemical gradient, but the movement of positive charge or from this inside to the outside, that means the efflux of this positive charge is actually prohibited. And here comes the role of ATP driven pump. Okay, so this ATP driven pump can actually go against the chemical concentration gradient, also against electric potential, also against both the electrochemical gradient. Now ATP driven pump also establish and maintain the ionic gradients. What is ionic gradients? As you can see, this is the example of ion gradients across plasma membrane of mammalian skeletal muscle cells. The extracellular concentration of sodium, potassium, calcium, and chlorine is actually different than the intracellular concentration of all these ions. And this concentration difference or chemical concentration difference is established by ATP driven pumps. These pumps actually promote the movement of this sodium, potassium, and that's why it actually maintain or establish the ionic gradients. As you can see, the external concentration of sodium is higher than inside, so naturally sodium will try to move inside the cells and potassium will try to move out of the cells, and similarly calcium will try to go inside, and chlorine will also try to go inside the cells. And these are the different types of ATP driven pumps. One is called P class pump, another is V class pump, F class pump, and ABC superfamily. I will also make separate videos on all these different ATP driven pumps, but the basic fact is there always ATP will be break down into ATP, and that energy will actually helps to move the molecule or ions from lower to higher concentration. That means it performs active transport. Hope this video will help you. If you have any doubt, you can write me in the comment section. Thank you for watching, and always keep learning.